Okay, do you all do the notes that I tell you to do? Afterwards, I will call one by one to answer it lah, huh? Okay, fill in the blank. Okay, so today we will start normal distributions. Okay, so I share screen now. Can you see your screen?
Yes.
Okay. So you write today index. Continue in the same exercise book. Okay, because this is still in chapter 5. So remember before your school holiday, chapter 5, we have random variables. Then under this random variable, you have two types of distributions. Okay, so one of it is a binomial distribution, and then second one will be your normal distributions. Okay, so today we come to normal distributions. Okay, so you write the index for today. Okay, normal distributions. Okay, today already 15. Okay. So we go through a little bit. Okay, we want to see what is the relation in between this binomial distribution and the normal distributions. Okay, before that, actually, you know, okay, when you learn a random variable, okay, there are two types of random variable. Okay, one is a discrete law. Okay, discrete random variable. Okay, this one actually means the binomial distributions. Okay, the other one is a continuous. Okay, random variable. Okay, this one refer to the normal distribution actually. Okay, but and yet we want to still see what is the relation in between this binomial and the normal distributions. Okay, we look at this. Okay, from the binomial distribution that you have studied, the size of the sample chosen are usually not big. Okay, we don't deal with the big size. Okay, the n. Okay, the size is the n. The size of sample. Okay, the n actually usually will use a small number. We will not use a big number. Okay, because we want to get one by one example. If your n is 3, so normally your sample for the x will be 0, 1, 2, and 3. Then you got to calculate one by one. Okay, when x equal to 0, when x equal to 1, when x equal to 2, when x equal to 3. You got to calculate one by one the probability. Okay, you imagine if your n is let's say here they make it 30. Okay, then your x will be from 0, 1, 2, 3 until 30. You imagine you want to calculate one by one, 31 of this, the probability. Okay, it's quite impossible actually. Okay, so if a sample of size n becomes large, for example, n bigger than 30, and the p, still remember the p is the probability for success. Okay, this is how you write the binomial distributions. Oh, sorry, I write wrongly already. X binomial and then np. Okay, so n is the size of the sample and then p is the probability for success. Okay, so what will happen if we calculate its distribution by using a binomial distribution method? Okay, so this is what I say. If the n is more than 30, let's say it's 30 lah, you got to calculate one by one the probability, means 31 of it. Okay, so it's quite impossible actually. Okay, so when the sample n become large, the calculation can become complex and the value cannot be obtained from the binomial table. Okay, so when the sample space n become large, we can estimate the answer by using a normal distribution. But this is just a estimations. Okay, you can use a normal distribution to estimate. Okay, when the sample size n is become large. But this one although we explain here, but we don't have any questions deal with this type of example, okay, when it's a binomial distribution, but the n is very big, okay, which is like bigger than 30, something like that. And then they want you to use a normal distribution instead of binomial distribution to get the answer. Can hear me clear or not? Because now it's raining quite heavily. Can hear me clear or not?
Yes, can
Huh?
hear you.
Yeah, can hear me. If can't hear me, then you have to tell me. So I, I will do something. Maybe I got to shout or what. Okay. Okay. So, another is they want to know how big is the n then is considered is big. Okay. So below are the conditions needed to determine whether the size n is large enough or big or not. Okay. So one is n times p is bigger or equal to 10. Okay, then we will say, okay, the n is large enough. Okay, p is the probability for success. Okay, and then the other one is n times 1 minus p. Actually, this 1 minus p is the q. Okay, which is the probability for failures. Okay, so n times q, okay, also is greater or equal to 10. Then this one we consider is large enough. Okay. But we so far I don't see any questions that related to this subtopic. Okay, but you just have to know, okay, for binomial distribution, if the n is large, then it can be estimated, okay, by using normal distribution. Okay. Next, we come to see this. Okay, we come back to normal distribution as a continuous random variable. Okay, look at this. Give 4 examples of natural phenomena that can be represented by a normal distribution. Okay, can anyone want to give an answer? Because you have learned what is a continuous random variable, what is the example. So I think you got no problem to give me, okay, the answer. Okay, maybe I can call name here. Okay, Kritika again today not here. Okay, I see Shuda here. Okay, and then Sophia, Sonia Sri, and Teo. Okay, 4 of you can give me the answer. You can type also. Okay, if you don't know the answer, 4 of you, if you don't know the answer, just on your mind or type in the chat, say you don't know the answer. So we don't wait for you. Then we will give chance to others. Okay, come. The question again. Okay, the question again. Okay, give the example of natural phenomena that can be represented by a normal distribution. Okay, you have learned during the random variable, you just give the example which are the continuous random variable.
Teacher,
Yeah, who is that?
Sophia.
Okay, Sophia. Yeah.
Height of people. Blood
Height of
pressure.
people. Very good. Okay, height of people. Okay, Sophia answer. Okay, height of people. The other three. Ayo, what's happening? Okay, weight. Can you give which of what of maybe which of watermelons, which of okay human, okay, which of people? Okay, so this is 2 example already. Just now you learn science, huh? Okay, this is for module. Okay, do I have a more answer? Okay, so Shruda and Sonia Sri. Light. What's the meaning of light? How do we measure light? Like example, just now Sophia give the height of a people. Then we measure in maybe in meter or in centimeter. They got reading. Then Xingzi say that weight of a people. So we measure in a kg. Also got reading. So what is this light? Huh? Rolling a dice? No, rolling a dice, you are getting 1, 2, 3. That one is countable. That one is discrete, not continuous. This dice is discrete. Tossing a coin also is discrete. All this under the binomial. How is it Sonia 3 here? Okay, I think I don't wait for answer anymore. Okay. Yeah, Sonia 3. Sound I mean how you sound or what? You measure sound, you measure light. Or maybe it's not that common. Yeah, okay, blood pressure. Okay, blood pressure can. Distance. Distance or what? Maybe can this way. Okay, distance from student's house to the school. Then different students have a different distance. Okay, you have to be more specific. Okay, so okay, can student distance from student's house to the school. Okay, very good. Then you have to revise more. Okay, just now you give me the answer for dice and the coin. That one is not. Okay, so all this is the example for the continuous random variable. So all these it can be represented by using the normal distributions. Okay, so we continue with a normal distribution as a continuous random variable. Okay, so you can take out the notes that I asked you to fill up. Okay, you start now. Okay, what is the normal distribution? A normal distribution is okay, what function? Is a type of what kind of functions? Okay, so we follow name list. Okay, we start over again. Farah, the first one. So we follow name list. You all please get ready the answer. Farah is what type of functions? Okay, probability function. Very good. Okay, means you all are prepared, well prepared. Okay, if you can answer me very fast without put me waiting, then means you are ready. Okay, to answer my questions. Okay, so it's a poor. Okay, the rest if you don't know or you didn't get a correct answer, please write it down. Okay, probability functions of is what type of a random variable? Is it discrete or is a continuous random variable? Okay, next girl. Jessica not here. Okay, Suping.
Continuous.
Okay, continuous. Thank you. Okay, it's a continuous random variable. Okay, next, the distribution is symmetrical with most of the data clustered around the what? And then close to what? Okay, one by one. Okay, the next answer is clustered around the what? Okay, means all together at certain place. Okay, at what place? Okay, next girl is Lydia.
Around the center.
Okay, around the center. Very good. Thank you. Center. Okay, close to the what? Okay, the center is also is something of these distributions. Okay, so next girl is Shahira. Close to the what? Okay, to the mean. Thank you, Shahira. Okay, mean means mean is the average, average of the data. So it's at the center of the of the distribution. So most of the data actually is around that. Okay, that is a peak of that. Okay, is also is at the center where the mean is. Okay, next, the probabilities of the data further from the mean taper off. Okay, taper off means become thinner. Okay, taper off. This word it means become, sorry, thinner. Okay. Okay, then become thinner. Okay, taper off what in both direction. Okay, is equally or unequally. Okay, next go. Okay, region. Okay, equally. Thank you, region. Okay, so it become thinner. You can see the bell shape of the graph. Okay, at the two side it become thinner already. Okay, and then but you still can see it's equally at the both direction. Okay, so they are symmetry. Okay, then we go to next. In general, the notation used for a continuous random variable x, which has a normal distribution is, okay, this one may be difficult for you to answer. So I will write down the answer. Okay, we write in x. Okay, and then n stand for normal distribution. Same thing like your binomial distribution, followed by a bracket, and in between is a comma. So the first one is the mu, which is the mean. This one means. Okay, the second is sigma square. Okay, this one is the variance. Okay, so this one is the notation for these normal distributions. Okay, now we come to the graph. Okay, here also there's something for you to fill out. Okay, here also there's something for you to fill out. And then these two actually repeat in the text also. Okay, so we come to the graph first. Okay, Ravania, can you please tell me what is equal to what and equals to what? Why I can't make it become smaller? What's happening? Okay. Yeah, okay. So mean is equal to a median and equals to mode. I think you all look at the textbook. The textbook actually got mistake. The mean, MIN, is spelled for the mean from Malay version. And then the mode, MOD, also is a Malay version. So for English version, mean actually had to be MEAN. And then mode had to be MODE. Okay, the textbook also got mistake. I adjust it become smaller so I can see both. Easier for me. Okay. Okay, so I write for you the answer. This one should be mean, MEAN. If you write MIN, please change, and then median, and then also mode. Okay, this 334 as here. This point. Okay, the middle point, or also is the highest. Okay, highest graph. Okay, highest point of the graph. Okay, next, what is this percent and what is this percent? Means the green color ones, okay, occupied how many percent, and the purple color ones or the gray color ones occupied how many percent? Okay, we go to next girl. Ruzaina not here. Okay, Sarah. Okay, 50 and 50. Thank you. Ruzaina here. Okay, Ruzaina, sorry. Sarah, answer first. Can you answer the next questions? Okay, number 1. What shape is this, Ruzaina? Okay, bell. Very good. Then is a critical here already. Okay, let me check. Okay, no, she's not here. Okay, we go to the next questions. Okay, mean is equal to median. Okay, this one I fill out because it's in the diagram. Same thing. Okay, and then it's equal to mode. Okay, all these are the concept is very important, especially in paper 1. Sometimes they do ask. Okay, then symmetrical about a vertical line that passes through the what? Okay, which is the okay notation. The notation of this is the mu. Okay, next girl. Shalin. Okay, mean. Okay. When you see this symbol, mu, okay, refer to mean. Okay, next. Okay, the graph is symmetrical about an axis at the where of the normal distribution. Okay, next. Okay, Shuda again. I hope you are prepared. Center. Okay, very good. Okay, the axis of symmetry is at the center. Okay, next, okay, the mean, which is the mu, divides the region under the graph into two what parts? Equal or not equal? Okay, Sirania. Okay, equal. Okay, there. Equal parts. Two equal parts. Okay, then how many percent of data values is less than the mean and how many percent of the data value is greater than the mean? Okay, so this one is also in the graph. So I fill out for you. This is 50% and this is also 50%. Okay, we have settled number 4. Now we go to number 5. Okay, the curve has a what value? Okay, at the axis of symmetry, okay, which is the x equal to mu, has what value? Siti Farah, I try not to give you option to choose. Okay, maximum value, very good. Means you already go through the text, okay, and then get the answer done. Huh? Okay, this is maximum. Okay, so you see here, you have a maximum value when at the axis of symmetry at this line. The dotted line, this is the axis of symmetry. At this point, you have a maximum value. Okay, the highest, the tallest point of the bell-shaped graph. Okay, number 5 we settle. Okay, now we go to number 6. The total area under the graph, okay, is equal to the total probability of all outcome. That is how many units squared? Okay, next is Sophia.
1.
1, very good. Okay, so this is very important. You remember the total probability for all outcome is 1. The total area under the graph also is 1 because the area under the graph represents the probability. Okay, next, area under the graph for x from a negative infinity to infinity represent the probability which is given by, okay, p and then in bracket, okay, x from negative infinity to infinity, which is equal to Sonia 3. What's the answer? Sonia 3. You're not sure. Okay, actually this one, okay, is at the back. You know, the summary of the notes. Okay, never mind. I will give you another chance to answer another questions. Okay, can Xingzi help? What is the probability if from a negative infinity to infinity? Okay, it's similar actually to number 6. Okay, it's 1. Okay, thank you. Okay, it's similar to number 6. Okay, the same meaning. It's just a different way of writing. Okay, so now Sonia 3, maybe you answer this. Both ends of the curve extend infinitely. Okay, indefinitely. What? Touching the x-axis. Without, oh, thank you. Okay, what's the meaning of this number 8, which is the last one already? Let us see the graph. This part. You see or not? Actually, the graph didn't touch the x-axis. Both sides also the same thing. Okay, no matter you know how you extend some more, how you extend some more, also the graph shouldn't touch the x-axis for both sides. Okay, this is the meaning. Without touching. Okay, the x-axis. Okay, so this is for the normal distribution graph. Okay, we come back to the textbook. Okay, before that, Sonia Sri give you 1 mark. Okay, Zingzi give you 1 mark. Okay, we come back to the textbook. Okay, so this part actually we are done now. Okay. Okay, next we come to see this. Okay, look at this too. Okay, if you want to add in your notes, okay, you can do so. Okay, if we have two normal distribution graph, okay, these two, the sigma actually the standard deviations are the standard deviation is the same, but the mean, which is the mean, are different. Okay, so how the graph will look like. Okay, if the standard deviation are the same, the shape of the graph do not change, remain the same. Okay, the shape is the same. It's like, you know, you copy and paste here. You copy this pink color graph and then you go to another place and paste it here. Okay, and then if how to say, the mean is the different, so the one with the larger mean, it will be more on the right hand side. Okay, so this one, the larger the mean value, the more to the right the position of the graph. Okay, this one you have to know. Okay. Number two, okay, in this case, okay, now you let the mean is the same. Okay, make the mean the same. Okay, this one is the standard deviation same. Okay, so now you have a different standard deviations. Okay, so we will see what will happen. Okay, standard deviations affects the height and the width of a graph, but the position does not change. Okay, you see around, because you keep the mean. Okay, therefore the axis of symmetry for both graph is the same. The position of the graph remain the same. Okay, next. Okay, the larger the standard deviations, okay, the larger the dispersion of the normal distribution from the mean. Okay, what is this meaning of the standard deviation? Okay, standard deviation is actually the dispersion of the value. Okay, if standard deviation is bigger or larger, then the dispersion will be bigger. Means it will spread wider. We can say this way. It will spread wider. Okay, so you see the blue one and the pink one. Okay, the blue one is spread wider. Okay, the blue one, the standard deviation is bigger or larger than the pink one. Okay, once the graph spread wider, okay, therefore this one will bring down the height of the graph. Okay, the height of the graph will go down. Okay, so these two you have to know. Okay, when you keep the same standard deviation, then different mean, okay, what will affect the graph? And then if you keep the mean the same, okay, then different standard deviation, how it will affect the graph. Okay, these two you have to know. Okay, okay, next we look at this. Okay, so as you know, this is a normal distribution graph. Okay, just now that questions, you still remember? Okay, the area under the graph for the whole graph is 1. Okay, but now let's say I want to take is only from the A to the B. Okay, so the area under the graph, this part, okay, is the probability. Okay, so the area under the graph for x from A to B represent the probability for x occurring from the value of x from A to B. Okay, it's written this way. Okay, why is this? You have an equal here and then this one without equal sign, this one with equal sign. This one means either one you can use. Either one you can use. You can write in this way, you also can write in this way. Okay, to represent the area under the graph from the A to the B. Okay, notice that the above two probability are the same since the normal distribution function is a continuous function. Okay, because normal distribution function is a continuous functions. Therefore, by writing the equal sign or not equal sign here, this one, not no equal. This one got equal. Both for these two, actually, they have the same meaning. Okay, we look at this. Actually, this one I think is a mistake of the book. This one, it should be binomial. Okay, binomial distribution. Okay, what will happen to the binomial distribution if n is very big? Okay, this one we can see the graph. Okay, I straight away open. I opened beforehand already. Okay, this one, if by default, okay, you can see this is a binomial. Okay, the calculation is here. Okay, this one is okay because you are not calculate by yourself one by one, no? Okay, this one is calculate by formulating they put in already the formula lah. Okay, so you can see all the value will come out from 0 until 20, 21 value of this. Okay, all the value will come out, and then you can see when you see the shape of the graph actually is like a bell shape. So we can so that we say that this binomial distribution is we can estimate by using the normal distribution because the graph is look alike. Okay, then you can see actually the value all concentrate in the middle. Okay, and then towards the end, okay, at the two side you can see from the table here, the number is very small already until it cannot be shown now. But actually it's not 0 maybe, but it's a very small value. Okay, let us change to maybe 30, see what will happen. Okay, if 30, you see, same thing, the towards the two ends is getting more and more value is very near to 0. Okay, and then same thing. Okay, the middles will be the taller. Okay, this part. Okay, if you want to change the area, okay, you can. Let's say you want to change to 14. Okay, and then to 18. Okay, okay, then they will give you the probability. Okay, means you add up all the probability. Just now is I put what 14. Okay, they add up the probability from 14 to 18. Okay, if I change this to 100, very small idea. Okay, then you see the data they calculate. Okay, from the 0 until 30, all are 0. Okay, then start from 31 only you can see some value. Okay, and then same thing, the peak is at the 50 around here, the mean, okay, the middle. Okay, and then after the 69, start from 70 to 100, all are 0. Okay, so this is why we say that we can estimate the binomial distribution that with big sample size. Okay, we can estimate it with the normal distribution. Okay. What's the time? Okay, 12 or 21. Okay, we go through two examples. Okay, we continue in the textbook. Okay, look at this. Okay, the diagram on the right shows a normal distribution function graph which is symmetry at x equal to 35. Means here. Okay, this is the mean. X is equal to 35. Set the mean value, mu. Okay, so settle, mu is 35. Okay, remember mu is the axis of symmetry, the middle one. Okay, B. Express the shaded region in the probability notation. Okay, so it's from 28 to 42. Probability notation. So it start with P. Okay, and then X in between 28 to 42. You want to put equal sign, you don't want to put equal sign, the same thing. Okay, both are correct. Okay, look at C. If the probability of the shaded region is 0.64, 0.64 here, this is 0.64. Okay, the purple color one is 0.64. Find probability for the x smaller than 28. Means what? They want this. They want the area. Okay, for the x smaller than 28. Okay, I put the dot, dot, dot. They want the area of this. Okay, you still remember the whole bell is 1. Okay, if the whole bell is 1 means what? Half of the bell is 0.5. Okay, and then they say that the shaded one 0.64 is for these two. These two are symmetric. Okay, therefore you can divide by half. Okay, 0.64 divided by 2. Okay, so you get 0.32 each side. Okay, here is 0.32 the area, here another 0.32. So now they're asking the dot 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 one. Okay, how big is this area? Okay, you know already from here to here is half of the bell, so it's 0.5. Means here and here altogether is 0.5. Okay, so you just get 0.5 minus 0.32. Okay, then your answer 0.18. Okay, we see another example. Okay, a continuous random variable. Okay, x equals x is a normal distributions. Okay, with 2.3. The first number, still remember this one is mu, which is the mean, and then the second number is the sigma square, which is the variance. Okay, I hope you still remember the variance and the standard deviations. Okay, so the standard deviation squared, okay, is the variance. Okay, so state the mean. Okay, so mean is 2.3 and the standard deviation. So you just get 0.16 square root it, okay, to get the standard deviations, okay, which is 0.4. Okay, so all this you see, even though it's not difficult, but you know, along the way, maybe you will forget all this basic knowledge. Then all this usually they will ask in paper 1 more. Okay. May I know what do you have after this?
Tutorial of
Huh? Tutorial of what subject?
maths.
Huh?
Mathematics.
Mathematics. So your teacher asked you to do what?
She gave us a book in DC.
Quizzy. Oh, so you all have to be punctual and then do, is it? Or can do afterwards in the afternoon?
No, she gave us some work in Google Classroom.
Oh, okay. So can you do it maybe in the afternoon?
I'm not sure about that.
Do you have to follow exactly the time given and then hand in before maybe 1 o'clock or what?
Yeah, teacher tell like that.
Have to hand in before what time?
1 o'clock.
1 o'clock. I do. Okay. Let me continue a little bit more. Okay, this is
No,
random.
1:30.
Sorry,
1:30, 1:30, sorry.
1:30. So you have 1 hour to settle it.
Mm.
Can finish or not? If can finish, then let me continue to teach. Okay or not? Vanessa want to represent the whole class.
Teacher, I don't know, teacher.
Okay, I will try to stop, okay, punctually. Oh, what is this? I don't want to see more news. What is this? How do I close this? How? How do I close this? What happened? Okay, come. Okay, random variation and the law of a large number. This one I don't want to touch more. This one, the old syllabus we don't learn this. Okay, we just I just show you one simple example. Okay, you just look at this paragraph. Okay, this example. Okay, consider a coin is tossed 10 times. A possible outcome of them can be 7 times heads, even though we expect only 5 heads. Okay, because coin, you know, there are only 2 possible outcome, which is head or tail. So if by percentage is 50%, 50%, okay, 50% you will get the head, and then 50% you will get the tail. Okay, this one is how to say, what we expect lah. But real life, if you do only 10 times, maybe it's not like that. Okay, maybe it can come to a 7 times of heads lah. Okay, maybe it can come to 6 times of head lah. Nobody will know lah. Okay, this is real life. Okay, but if you toss the coin, let's say 10,000 times, oh, this is very, very big. Okay, so the expected number, okay, even not exactly fall at 5,000 times, which is a half of the 10,000, okay, but it will be very close to the 5,000. Okay, it will not longer to have maybe 6,000 or 7,000 if your number of trial is big. Okay, this is the law of large number. Okay, so what we want to see here, okay, you look at this. Okay, the larger the sample size, the smaller the random variations. Okay, means it will not vary so much. Okay, if the sample size is big. Okay, so the estimated value of a parameters becomes more consistent. Okay, so your expected value will not different that much from your expecting value. Okay, this is the meaning. Okay, so nothing much actually for this part. Just they want to introduce to you what is this random variations and the law of a large number. Okay, then maybe we go to this. Okay, the law of a large number. Okay, this one. Okay, the law of a large number states that the larger the size of a sample, the value of an experimental means get closer to the theoretical means value of the population. Same like what we said just now. Okay, the larger the size of the sample, okay, then your experimental mean will get closer to the theoretical mean. Okay, the theoretical means here is the expected one. Okay, the expected mean. Okay, the expected mean. Okay. Okay, can give me 5 to 10 minutes. Ayo, kasihan you want to eat, is it? Let me finish this. Huh? Can Just that I shouldn't let you rest, But I kasihan you I know your teacher let you come out late, Ayo, then you continue with mine. Okay, now I don't ask questions lah. Okay, I give you the answer for this. Okay, we look at this. Okay, your notes second page. I hope you print out. Okay, and then you can stick inside your exercise book. Okay, we come back to the text a while. Okay, we continue with this. Why do we need this standard normal distribution? Okay, what is the difference with standard normal distribution and the normal distribution that we learned just now? Okay, this one we have a word standard. So next time, when you read questions, you got to be very careful whether this is a normal distribution or this is a standard normal distribution. When you see the word standard normal distribution, it means different, okay, from the normal distribution. Okay, we look at this 1, 2, 3, 4, the 4 curves here. Okay, the diagram on the right shows 4 curves with normal distribution. Can all these distributions be standardized so that we can compare them? So you know the purpose why we have to make it standardized, because if we don't make it standardized, we are not able to compare them. Okay, this is the purpose. We want to standardize the normal distributions. Okay, you look at 1, 2, 3, 4 here. Yeah, so they have these three have a same mean. Okay, but the fourth one have a different mean from the first three. Okay, then 4, 4 also have a different variance. Okay, after this we will refer back to this graph again. Okay, what we want to see the properties of the standard normal distributions. Okay, now we go to the notes. Okay, this to compare normal distribution and standard normal distribution. Okay, normal distribution we label it with this X. Okay, but standard normal distribution we label it with Z. Okay, and also we call it Z score. Okay, and then it's very clear that okay, the mean, okay, the mu here for standard normal distribution is 0 and the variance is 1. When the variance is 1, the standard deviation also is 1. Okay, then you can see because the line of symmetry, okay, is the highest point of the graph, okay, therefore fall at the axis here, okay, because the mean now is at 0. Okay, so this is the difference in between this graph, normal distribution graph, and the standard normal distribution graph. Okay, here is the mean. Okay, mu is 0. Okay, a standard normal distribution is a graph used for comparisons with all other normal distribution graphs after their score are converted to the same scale. Here is same. Where's my pen? Okay, same scale. Okay, means all convert become the means is 0 and then standard deviation is 1, all converted in that way. Okay, so they have a same scale, therefore they are compatible. Okay, you can compare each of them. A continuous random variable Z is the standard normal random variable or Z score. Okay, so remember the name. Sometimes they don't tell you that one is a standard normal distribution. They will just tell you that it's a Z score. Okay. Okay, here the mean is 0, standard deviation is 1. Check your answer, please. Okay, a continuous random variable, okay, with mean is mu, standard deviation is sigma, can be standardized by changing it to another continuous random variable Z. Those mean is 0, standard deviation is 1 by using the following formula. Okay, this is very important. This formula, got to remember for normal distribution. So the X, the original X, the random variable, okay, you got to minus with the mu and then divide by the sigma. Okay, the mu is this and then the sigma is this. Okay. So remember always if this one is given, this is not the one to apply it here because this one got square. This one no square. Okay, so always what you want to apply here, this one you got to square root it before you put it here. This is a very common mistake made by the student. Okay. Okay, I hope you have copied down. Okay, then the last part for this calculator is next lesson. Okay, this one I will explain to you. Okay. So this part done. Okay, then we come back to the textbook a while. Okay, so now you look at this 1, 2, 3, 4. Okay, which one is the standard normal distribution graph? Okay, this one, no? Okay, the mean is 0 and then the sigma is 1. Okay, sigma square is 1, then sigma also is 1. Okay, so this red color one is the standard normal distribution graph. Okay. Okay, this part done, this part done. Okay, then we go to this a while only. Okay, this one they just want to let you know. Okay, actually this part just now you still remember this. This one. Okay, the same thing. You see towards the end actually not much of data here already. Okay, so this one the same thing. Okay, towards the end actually very little percentage is occupied here. Okay, mostly the data is in the middle. Okay, so here they make an analysis. 68% of the data lies between standard deviation 1. Okay, then 95% of the data lies between the standard deviation 2, and then 99.8% lies in between the standard deviation 3. So actually you can see, okay, from the middle, here is 3, and then here is minus 3, is cover almost, can say, all of the data already. The rest actually is very little, very little towards the 2n. Okay. Where? Okay. Where did I go? Okay, so this part you don't have to memorize. Okay, this one is just for you to know. Okay. Then we will go through one example, then that's all for today. Okay. We want to see how we make use of the formula just now. The z equals, okay, x minus mu divided by sigma. Okay, a continuous random variable x is normally distributed with a mean 30 and the standard deviation of 8. Okay, find the z score if x equal to 42. Okay, if I want to write it out with the notations, this is a normal. Okay, 30 is a mean. Standard deviation is 8. But here you got to write variance, so you can write 8 square. Okay, so when you apply, remember this is 8. Okay, don't put 64. You can write 8 square. Okay, so you just use this formula. Okay, find the z score means you find the z. Okay, the x is 42. So here is 42 minus the mu is 30, minus 30 divided by the sigma is 8. So divide by the 8, then you get the answer. Okay, but B, the height of a building in normal distributed with a with a mean of 22. Okay, variance at 25. This one you have got to be careful. Okay, 23 is a mean, variance is 25. Okay, so this one you don't write 25, you can write it as 5 squared, so that you are ready afterwards to use a 5 here. Okay, normally I will suggest the student don't write 25. Straight away write 5 squared. So after you remember, you are using 5, not 25. If you are using 25 here, sorry, everything gone. Okay, so same thing, you put in the formula. Okay, find the height of the building if the standard score. What's the meaning of this? Standard score means the Z. If you don't understand this, then you will put the X as the standard score, then wrong. Okay, so the Z is 0.213. Okay, find the X actually. Find the height of the building. Find the X. Okay, minus 23 is the mean. 23 is the mean. And then divide by the variance, the standard deviations 5. Okay, then you get the answer for the X. Okay, that's all. Okay, so you can do this exercise and then one more exercise. Two exercises. Okay, one more is here. Okay, so 5.10 and 5.11. Okay, wait, I take attendance.